Yeah, so be careful with those absolute value bars. Guys, in your homework, you should have indicated, because we did it in class together. Come on, open up. Come on, open up. You should have indicated that these are absolute value bars. So, like, that's how we get 13 in C. Other questions on 223? Other questions? Guys, if you don't have your homework done, do it over the weekend. Do not hide behind, oh my gosh, I didn't do it. Woe is me. Questions? Questions? On which? 77? Oh, we're definitely not there yet.
Oh, okay.
Yeah.
Sorry.
All right, we all good on 223? All right, scrolling on to 224. Let me get that back out. All right, so yesterday we were talking about breaking up numbers to make them work slightly easier. So in A, and I forget if we did this in this class, guys, I'll be honest with you. A feels silly. A, to me, is probably just as easy if I do 12 plus -4 and then just do 6 times 8. That's probably just as easy. However, in B is 7 times 290, right? This number right here, 300 plus a -10, that's 290, and I can't do that math. Really, I just can't. I don't know what 7 times 29 is. I definitely don't know what 7 times 290 is. But I could do 7 times 3. And I could also do 7 times 1. That is why we're going to break this number up. We make it 300 plus a -10. What is 7 times 3? 21, and then put 2 zeros on it. Right? The 2 zeros from the 300 come down into our answer. Then 7 times 1, well, we know what that is. 7, but bring that 0, so it's really 7 times 10, right? 70. Make sure you bring the negative. So then it's 2100 and a -70, so 2030. Same sort of thing in C. I know this wasn't part of your homework, but like 80 is, like number 80. And we can go over that one too. So in 80, how would we break 410? Yeah, 400 and then 10. What is 9 times 4? 36. Guys, if you didn't do 80 yet, pick up your pencil and do it with me. I really do not understand kids that haven't done their homework and just sit here and do nothing. I get it if you haven't done your homework. That happens. But I'm doing it for you. So do it, because then it's done. 9 times 4 is 36. How many zeros? 2. 9 times 1. And then put that 0 on. And now add them together. 3,690. The B, I'm going to do B over here. 6 times 500 plus 90 plus 2. 6 times 5. Oh, I forgot an arrow over here. Yeah, thank you. 30 and then 2 extra zeros. 6 times 9. Yeah, 54. And then an extra 0 comes down. And one more multiplication to do. 6 times 2? 12. 3,552. All right, back to our answer key here. We got some magic diamonds. The top is the product, right? It comes from multiplication. We're going to do 84 together. So if you got a question on 84, we're going to do it together here in a second. John.
Are we putting this homework in once we're done checking it?
If it's done, yeah, otherwise just turn it in on Monday. Yeah, so if you have it done, then yeah, get rid of it, right? Get it out of your binder.
I was just wondering if we were supposed to, or if we were supposed
Yeah.
to wait.
Nope, thanks, man. Once we check it, you're good to turn it in, right? We normally wait because we haven't checked stuff yet. A histogram. A histogram. Guys, a lot of us probably don't know what a histogram is, so please give me your focus. We take this data, right? Look at 84 with me, if you, especially if you need to. We want to show this data on a graph where it tells us, and 88, where it tells us how focused our information is. So guys, think about it like this. If you run a store or anything and you're trying to decide like, well, what sort of magazines should I sell? Or what sort of candy bars should I sell? Like, we collect data and we figure out like, well, where are most people, like where are like the highest frequency is the word I'm trying to say, but I'm trying to think of a simpler word and can't really. So, you take your data and you split it up. Guys, your histogram does not need to look just like this. Your histogram does not need to look just like this. All that matters is that the bins, I don't know why we call them bins, but we call these bins, that the bins are all equal widths. So how wide is this? 15, right? 30 to 45. So this has to be 15 wide, has to be 15 wide. If you make yours 10 wide, from 30 to 40, 40 to 50, 50 to 60, that's fine. You don't want to make them like too wide, because then there won't be many different bins. The y-axis has to be how many, right? Frequency is how many. So there were 2 points of data in the 30 to 45 range. There were 3 in the 45 to 60. If we look at your paper and count up, there were 4 in the 60 to 75. And how many were here? 7. So most of our data that we're looking at is right here. Most of our data is right there. That's why we do a histogram, is to say, well, where is most of my data? So think about if we were doing ages of Phoenix. What age are most of you guys? Like 11 to 13, right? Like 11, 12, 13. So if we were doing ages, there'd be like very few people down in like 0 to 10, right? Like any of those ranges. But there'd be a lot in the 11 to 13 range. This is why we look at histograms. We will do more with histograms. This is very much like where CPM says, hey, here's a thing we're going to do more of later. Okay, we're going to do more with histograms later. Don't worry about this right now. Okay, it's just a, like, remember how to graph a histogram? Oh, we don't? Okay. Like, that's what this is doing right now, guys. It's telling us, oh yeah, you don't remember how to do this. Sorry, we have homework today. So 225 is our homework. I will try to give you time at the end of class to work on it. All right, this is on your handout. So please get out your 225 handout. It looks like every other handout that we have. So right here, we got part 1 and part 2 on our handout. If you don't have it, I've got extras over there if you were absent or missed it earlier in the week. I need you to work with your team to figure out how long is... Oh, it would help if I... you guys got to tell me when I think you're looking at something and you're not. Because if my screen gets locked, I don't always know. Alright, handout. Looks like this. So, once we say go, or whatever, you and your team need to chat about how to total up all of this in part 1, how to total up all of this in part 2, and then put the 2 parts together. If 223 and 224 are done, you can turn those in. Okay? Take a few minutes. Try this with your team. No calculators. In case we... Oh, man. You ruined it. Totaling up all of this. So, like, what is that multiplication? What is that multiplication? Add all these numbers together. Nope, no calculator. Yes. Thank you, Miss Galucci. 1 o'clock today. I think I already do that. You're more like a dentist, right? An orthodontist. My directions maybe weren't awesome. Here's the sort of work I'm looking to see. What is 3 times 2? 6. So put that there. What is 3 times 3? 9. So put that there. Now add all these numbers up. Right, then go down and do part 2. Now, yesterday, we realized you could add these together first, or you could distribute the multiplication. I have an idea of what will be easier there. Keep chatting with each other. Good catch. What's a positive 1 and a negative 1 together? Ooh, so, well, we can't add these up because this is attached to the parentheses. So we have to do the total times the parentheses first. So what's a plus 1 and a negative 1? 0. So this is actually 0. So that all disappears. So all we have is 5 plus the 3 of them. And be careful, you don't have the 4. So that's not 12. Right? Because 4 times 0 turns into 0. So that's what happens there. 4 times 0 turns into 0. So we just have 5 plus 3. Hold on just a second. Guys, what is a positive 1 with a negative 1? 0. And then, what is 4 times 0? 0. So be careful. This whole thing is 0. This entire little section right here is 0. Did I give you guys? Yeah, make sure you keep this out. I can't see the order. Oh, there's a little bit off down here. You're skipping steps. Like, what is this All right, give me your eyes up here. Guys, here's the problem with math. Math problem. Yesterday, we talked about the distributive property. That would say I can do 3 times 5, but I also have to do 3 times negative 2. But, guys, that's not always the best. Sometimes it's the best, but right now, could I do 5 plus a negative 2? Yeah, what do I get if I do 5 plus a negative 2? 3. So this section can really become 3 times 3. If you multiply, you're going to get 15 plus negative 6. What's 3 times 3? 9. So up here in the front, what's 5 plus 3? 8. Who can tell me the easier option right now? What to do? Yeah.
You could add -3 and -5 together.
Put your negatives together. What do you get when you do that?
-8.
Negative 8. Do you want to keep going?
Yes.
Keep going.
Take out the 8 because it's 0 together.
Oh, we have a 0 pair. A positive 8 and a negative 8. 0 pair. Ba-boom. Ba-boom. They're gone. 0 does nothing. So I have 9 and 1. What's 9 and 1? 10. We get 10 here. All right. For sake of time, we're going to keep moving forward because I'm just going to skip B and C for now. Pull this page out. If I can find that page. We're throwing it back to the homework really fast, which remember, I'm recording. So if you need to see this again, like later, you can go to the recording, but we're going back to 224 real fast. You're gonna need that resource page out. But all right, so I had a couple questions about this yesterday. Just got another question now, so definitely worth going over. Camille and her friends played games for 3/8 of her party. Hey guys, even if you don't need this, be respectful and just chill. They ate pizza for 50% of the time. I ate pizza last night. And the rest of the time was for presents. Guys, I like circle charts. Like, you can draw whatever you want, but I like visualizing things with circles. So I often default to just drawing a circle when it's asking me to break things up. So it says draw a diagram, make calculations for time spent opening presents. We'll get back to how much time. I just want to draw a picture first. 50% of the time for pizza and cake. Well, that's half of my circle. So pizza and cake. 3/8. I gotta split things into eighths, I guess. So this half would have 4/8. Kind of, they're decent. So make 3 of them games. So I'm going to go ahead and just highlight this stuff. You guys see that on the screen, all right? How much is left unhighlighted? 1/8. Because we know this side was 4/8. So 1/8 is our opening presents. Now this is a fantastic segue into today's lesson, actually. Because how do I then calculate the time? We got to do 1/8 of 3 hours. What did we say of tells us to do yesterday? Multiply. Be careful. Of tells us to multiply. And if I have a fraction, I'd rather work with both fractions. How can I turn 3 into a fraction? What do I put on bottom? 1. So then our answer, we multiply across the top, multiply across the bottom, 3/8. Now, if this was difficult for you, you're in luck, because we're practicing this today. So pull out this sheet, and actually, I'm going to, at the bottom of this sheet, I'm going to draw a different diagram. Nah. I mean, we could draw a rectangle diagram for the same thing, but we'll move on. I got a question for you. If Cameron is in gym with Mr. Smith, and Cameron sprints 2/3 of the quarter-mile track, 2/3 of 2/3 of a quarter mile. Go write that down on your paper. You can do it on the resource paper. You can just write that down like up at the top. 2/3 of 1/4. Now, what did we say of tells us to do? Multiply. So I want you to talk with your team. What is this? What is 2/3 times 1/4? Take like 30 seconds, chat with each other. If you don't know how, it's all right. Make a guess. We do not need common denominators. Give me your eyes. This, I'm going to say the bad word. This is easy. Now, look, you guys know that's a bad word. Like, I don't say that very often. Fraction addition is tough. Fraction multiplication is easy. Watch. We just go straight through the top, straight through the bottom. That's it. No common denominators. No, and I don't have to do, and I barely have to think. I just multiply. So what's 2 times 1? 2. What's 3 times 4? 12. That's it. Way better than addition. I know. Now wait, let's look at that resource page. How could we draw a diagram of 2/3 of 1/4. Chat with your team. How could you take this and draw 2/3 of 1/4? Is that an accurate drawing? Does that, like, if somebody looks at this, are they going to say, like, oh, that's 2/3 of a 4? Okay. All right, come back with me for a second. Let's say my wife and I get a pizza. Because everything's about pizza, Antonella. We eat half of the pizza for dinner. So over here, we're going to make half of the pizza. So go ahead and split this rectangle in half. Half of the pizza. And we're going to shade half of it because we still have half of it. Now for lunch today, we decide to split the leftovers. So I bring to school half of the half. How could I draw half of the half? But you just said what I asked. You can't just repeat the question as the answer. Idea? Well, last night I ate late night slice for what it's worth, but because I was downtown, so late night slice is awesome. Here's the trick. Give me your eyes up here, please. I could cut it this way. I could cut it I could cut a lot of ways. But here's what I need you to do. Since I just drew this direction, now I'm going to draw the other direction and shade in half of that. So half of a half is really going to be 1/4. So over here, if we want to draw 2/3 of a fourth, the first thing I'm actually going to do is draw my fourth. So let's make fourths. Split, split, split. Now here's the trick. These all have to go the same direction. We cannot make this into fourths like a T. And guys, you can just, if you did it wrong, move on to another one. You've got extra rectangles here. You've got extras. If you goofed up, it's fine. Move on to a different one. We're doing a fourth. So we did our fourth split. Now, going the other direction. Well, wait. Hold on. Sorry. I'm getting excited. How many of these should be shaded? One. 1/4. Shade it. Now, going the other direction, make thirds. How many of these should be shaded? 2. How many of these got shaded twice? 2 out of how many? And that's the answer we just got, right? 2 out of 12. So first we split it into fourths and shaded 1. Then we split it into thirds, shaded 2, and the doubly shaded. That is our answer. The doubly shaded. Let's try this with All right, new rectangle. Half the school is going on this trip. Shade in half a rectangle. Half a rectangle. Let's go this direction, the direction they go. So if you went the other way, just go to a new one. You got plenty of rectangles, guys. So let's make it look like what we have up on the screen. So shade in that bottom part. All right, so we should have a rectangle that looks like this. Half. Let's go ahead and write half. Half. But of the half going on the trip, 3/4 of them, 3/4 of them brought their permission slip. So what am I going to do now to my rectangle? We're going to cut it into fourths, but the other direction, right? Ba-boom. 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 How many of these would be shaded? 3. Guys, I'm going to start to use some coloring, I think. So if this was my half, so then 3/4. How many boxes got yellow and pink? Out of? So that's our answer. 3 out of 8. If you want to label this, guys, I'm trying to help make sure that we understand this. This was half. This was 3/4. So half of 3/4 is 3/8. If the school has 120 students, how many wanted to go and brought their permission slip? So if the entire rectangle, if the whole thing is 120, how many kids get to go, right? Brought their permission slip. So what are we going to do? 3/8 of 120. What does of tell us to do? We're going to do 3/8 of 120. 3/8 of 120. We can make 120 into a fraction by putting it over 1. What's 3 times 12? 36. So 360. Put that 0 on. So then at this point, we probably need to use a calculator. Who's got a calculator? Do 360 divided by 8. I think it's 30 something, 40 something. 45. What is it? 45. So remember, of tells us to multiply. 3/8 of the students. 3/8 of 120. Try this. Last night, Howie has 5/8 of his pizza left over. Ooh, so the first thing we need to do is split up our rectangle into 8. So guys, we have to do all of these the same direction. that would be like step 1. Keep going to finish this out. He then takes half of his leftovers to lunch. Or sorry, he eats them for breakfast the next day. Man, how he likes pizza.
You just
Oh,
do that.
your
I
judgment.
love pizza. I do that for breakfast. Yeah, I do that.
It's nutritious. It's got
Amazing.
vegetables.
I don't eat pizza with vegetables.
If I split this into 8s, how many should I shade?
5.
5. 1, 2, 3, 4, 5. Then we need to do half. So I need to draw another line. Other direction. Par? Sure. 5 over 16. I think you counted an extra 2. Yeah, 5 over 16. $88 is on your homework sheet. So if you still have 225 out, like your homework sheet. Joe is going to make half of his garden be carnations. I would underline this because it's on your paper. 1/3 of his carnations need to be red. What split am I going to do first? Actually, you bring up a good point. Order doesn't really matter. I could do 1/3 first. I could do half first. I just got to make sure I do both. So half is carnations. All right, half is carnations. And then 1/3 of them are red. So this box right here got double shaded. Right, because I had blue all through here. So how many is this?
1, or no, what's it?
Yeah, 1, 6. Now it's not necessarily Friday funny, but because we're now into October and we're almost out of time, so we might have to pick this up on Monday. I love Mark Rober. Have you ever seen the porch package thief thing? So